just review chapter 4 assignment part 2. But before we review, right, let's just go over a couple of the concept before we move further. Okay, so for the discrete, we have what? We have a discrete random variable and we have a continuous random variable, right? And then of course for each we have a distribution functions, right? Probability distribution functions. For the discrete, it's called PMF, probability mass functions. And for the continuous, right? For the continuous random variable, we have something called what? Probability density functions, right? And then for both, we have a cumulative. Now, for the discrete case, right? We talk about what? Basically, yeah, we talk about the binomial probability distribution, right? It's known as like Bernoulli trial, right? So binomial probability, right? Probability mass function actually, because the binomial is a discrete case. And then for the binomial, right, for the Excel spreadsheet, by the way, when this problem, right, this binomial probability distribution functions, right, like any problem that related to binomial distribution functions, of course, if the problem is simple, yes, you can use this formula, right? But I highly recommend that you use the Excel spreadsheet, right? So binomial distribution functions. Okay, I covered this, how to use this Excel spreadsheet, right, using the this function binomial.dist, right? I talk about it. Okay, and then for the next, now for the continuous case, I know that there are a couple of probability functions like uniforms and triangular, but we're going to skip those two, and then we're going to focus on the normal probability distribution function, right? So this is the curve, and then there are two, and then what? I ask you to kind of memorize this number, right? For this, about 68%, 68 of the values of the normal random variables are within plus the minus 1 standard deviation of its mean, right? About 68, 95 and 99.7, 99, so 6.8, 95.4, 99, so at least like first two digits, like 68, 95 and 99, right? And anything outside of this this one, right, this 3 standard deviation, right, anything outside of any data outside of 99.7, right? Those data are called outliers. Okay, and now for the important things that you should know about the Excel functions, it's the what is the functions? I think we covered this last lecture, right? So norm.dist, right? And this is what? This is the first variable is what? Norm. The first is the value of the interest corresponding to the probability you want to calculate. And then second, I think it's the mean, and third is standard deviations. And then fourth value is, if it's a true, then we want to cumulative, right? If it's false, then the actual probability, right? But typically we need to use, we typically will use true, right? Because the area, the cumulative, right? The area is that what we are interested in, right? Finding the area. So that's why most of the time we'll use true, right? Okay, and then we use the function, another function that I did not really cover last time. It's normal.inverse, norm.inverse, and the first value is the probability of interest. So it's not just the probability. I think we have to be a little bit more precise. It's a cumulative, the probability. Okay. So in this example, right? Let's just talk about this example that I mean, we already talked about this example in the last lecture, but let's see. So we have, right? Let me just open this. Where is my OneNote? Okay. Let's see. Right. So this is like my previous lecture, right? We talk about Nom.dist. By the way, I always upload my video lecture, right? So if you want to review this, and I highly recommend that you should review this for your midterm and your homework assignment, right? But we did not really talk about Nom.inverse, basically inverse function. So now let's talk about inverse functions, okay? So now, so if you look at this example, so I'm going to use this example in the textbook, right? So let's just use this example to explain how to use Nom.inverse, okay? So basically, the scenario, I mean the example, right? So we have a normal distribution, right? And then the engine, the lifetime in the flight hours, right? This the life expectancy of this engine. So this is the average is mu, right? The average is mu, and that's like 36,500 hours, right? So this is like hours, by the way, right? Hours. And then sigma, which is a standard deviation, is 5,000 hours, right? So this is hours, right? And then basically, so far, I mean, the thing is, if you use a norm, I mean, in the Excel file, right? If you use the norm, not the inverse, okay, norm distribution, right? The first input is the probability. I mean, not the probability. So this is the distribution, right? So this is like a value of your interest, right? For example, if he wants to have if he wants to find the cumulative probability, let's say this is like a 4. Oops, this is too thick. Oops. Okay, so if he wants to find the, let's say, cumulative, the probability, right? Where the, like, let's say this is like 40,000 hours, right? Right? So if he wants to find the probability, right? I mean the cumulative probability, for example, where the engine life expectancy is less than 40,000 hours, right? So that means you put the 40,000, right? So that the value of the interest. By the way, this is the hours, right? And then what? Then mean and standard deviations and the true, because true will give you the cumulative, as you can see, right? This is like cumulative probability, right? So basically, the norm.dist is going to return what? Return a probability, right? In case if it's a true, it's a cumulative probability. If it's a false, then it's just a probability, right? But so, however, oops. So let's see. It's not. Oh, that's too much. Okay. How? Okay. Okay. So I'll just draw one more time. Okay. So that's the normal distribution, right? Functions. Okay. It's too ugly. Okay. So that's our normal distributions, and then the mu is 365,000 hours, right? And then standard deviation is 50,000 and maybe the 5,000 hours, right? Okay, now, as you can see in this example, right? The company, right? This company wants to find out, let's say when this is given, like 10% of the engine eligible for the discount in the guarantee, right? Because the engine performance is not really great, right? So they, if your engine, right? If your engine is belong to this area, right? Meaning that it's their performance is poor, or whatever, right? So that is for the they can give you some discount, right? But they don't want to but they wants to be give you a discount price only if the engine is within the bottom 10%, right? So what the company wants to find out is like what is the guaranteed lifetime flight hours. So this is like opposite, right? So in the norm distributions, this is the something that you provide, and then you get in return you get the probability, right? But this case is different, right? What is given is the probability. So in this case, the given is the hours, right? And then return, right? This function returns the probability, right? But in this case, what is given is the probability, right? And then in return, they returns a value, meaning like in this case is hours, right? So basically the x. So what is given is 10%, right? Here is a 10%, the bottom 10%, right? And then you want to find out this value x, right? X hours. In that case, you can use a function called norm.inverse, right? Norm.inverse functions. And in norm-inverse functions, the first value that you have to provide is first argument, right? Is a cumulative, the probability. It's not just the probability, it's a cumulative, the probability. And then the second one is the mean, right? And the third one is standard deviations. Okay? And then it will returns this value. Okay? So that's the norm.inverse functions. Okay, so any question? Okay, then let's, okay. So that's like a norm.inverse function, that why we need this kind of function, right? Inverse functions. Okay, so let's take a 1 minute break, and then I'm going to talk about the assignment. Okay.